Hey everyone, I hope everybody's having a good semester. Today I'm going to explain to you all what I chose to do for my quantitative analysis project. I'm interested in football, so I decided to just again look at some NFL statistics. Okay, so to start things out, I chose to look at wide receiver and offensive tackle heights at the 2017 NFL Draft. My skewness and kurtosis values were all included, none of them were excluded, and they fell within -1 and -1 and +1 and -3 and +3. Okay, so to determine if this data set had equal variance or unequal variance, the F statistic value is less than the F critical value, so that means that they had equal variance. For my t-test analysis, I used a t-test with equal variance. My t-stat value was greater than my t-critical value, and this means that this information was statistically significant. Therefore, we're rejecting my null hypothesis that it would not be statistically significant. Okay, so for effect size on this data set, the Cohen's d value was 2.64, which is indicative of a large effect size. Effect sizes greater than 0.8 have a large pull on the data. Okay, so for my correlation analysis, I chose to look at would there be a significant relationship between the brawl jump and the 3-cone drill in the 2017 NFL Draft. Again, my skewness and kurtosis values, the data was not skewed, as the skewness values were between -1 and 1, and the kurtosis values were between -3 and 3. All right, so the R value for the correlation was 0.59. Therefore, that's a strong correlation. According to the significance table, this is significant at the 0.01 level. Therefore, we reject the null hypothesis. The effect size, this data had a large effect size due to the correlation coefficient greater than 0.5. And you can see there they had a strong correlation between the two. For my regression analysis, I hypothesized that height, weight, 40-yard dash, vertical jump, bench press can be used to predict an athlete's broad jump. My data is normally distributed. Again, my skewness and kurtosis values fell within normal ranges. During my initial regression analysis, I determined that height, weight, and bench press were not a factor that contributed towards an athlete's broad jump value, but the 40-yard dash and vertical leap could be used to predict an athlete's broad jump. So I'm rejecting my null hypothesis here, and you can see my regression equation in that they had a strong relationship between the two. For my ANOVA analysis, I chose to look at was there a statistically significant difference between wide receivers' weight in 2017, 2016, and 2015 during the NFL Combine. Again, my data was normally distributed, and the results from the one-way ANOVA showed that the data was not statistically significant. During the Bonferroni correction, again, none of my data was statistically significant, and this is supporting my null hypothesis. And then all of these had very low effect sizes, little to no effect on the data. Thank you all, and I hope you'll have a good day.